Okay, so we're going to start a unit on circles, and our first part is we're going to talk about central angles, arc length, as well as sector area. Here are our learning targets. Okay, so how do we find arc lengths and areas of sectors? Well, the first thing that we need to know is something called a central angle. And a central angle is kind of just the way it sounds. It's an angle with its vertex at the center of a circle with sides as 2 radii. So that just means if we look at this, right here is our central angle. It's in the center and the 2 sides, notice the vertex is at the center and the 2 sides, that's a radius and a radius. So that is what we call a central angle. So hopefully that makes some sense. One thing to note is that it intercepts an arc, and you'll notice this arc, let's go with this arc right here. That arc right there, that is the same as the central angle. So that also is called, this arc right here, okay, is also 84 degrees. Okay, it is, remember, a circle is 360 degrees all the way around. A semicircle, which is half of a circle, then is 180 degrees. Those are 2 things hopefully you have already in your back pocket. And so this arc right here that I've highlighted in red is called an intercepted arc, because that angle right here intersects with that arc. So we say it's an intercepted arc, but it's the arc that's formed there. So, okay. So we have 2 kinds of arcs. We have minor arcs and major arcs. A minor arc is going to be from 0 to so let's do it this way, up to 180 degrees, but not 180 degrees. So anything less than 180 degrees is considered a minor arc. So in this particular case, minor arc AC, which is the one that I highlighted here in red, right? That thing right there, that is 84 degrees. So the measure of arc AC is 84 degrees. Now major arcs, well, this one, minor arcs, 2 letters. And you'll see that right there, right? Use an arc above it with 2 letters, okay? When you do a major arc, you're going to do 3 letters. Because you need to know which way it goes around. And a major arc is always going to be, it's going to be bigger I wrote that the wrong way. It's going to be bigger than 180 degrees, or equal to 180 degrees, but then less than 360. Okay. So this major arc, then, what we would do is take 360, right? So this major arc, let's do this in a different color. That would be this distance around ADC would be that arc right there, right? So we want to know what that is. Well, we know that a circle is 360 degrees. So then we would just say, all right, well, if I take 360 minus 84, that'll give me what's left over. So that would give me 276. So this would be 276 degrees. Okay, so central angles, minor and major arcs, along with intercepted arcs. Hopefully that makes some sense. So that also then would mean that this angle in here is 276 degrees as well. Okay, hopefully You feel pretty comfortable with that. All right, so given all that information, we're just going to apply that to this problem right here. Okay, so it says find each angle and arc measure, and on the right, you've got a bunch of things, 5 things that we need to find. Okay, well, I notice that this line right here is a diameter, and it cuts the angle in half. So when you see that, you should think, well, from here to here is 180 degrees, and same thing this way, right? Those are semicircles. That's 180 degrees. Okay, so if I know that this is 72 degrees from S to W, T to U, arc TU is the same as its central angle, which is 87. So that means this has to be also 87 degrees. Now, if the whole thing from here, from U to W is 180, then I can just say, well, 87 plus 72. Okay, that's 159 degrees. So what do I have left? This arc right here, from T to S, or ST, I need to figure that out. That's one of the angles I need to figure out. So that should be 180 minus 159, which is 21. Okay, so this is 21 degrees. Okay, so I can fill in measure of arc ST is 21 degrees. Okay, let's do the first one. The measure of angle UXV. Okay. Let's see, UXV. Okay, well, it looks like this. If you remember, this is right here. That's, the arc is 72, which means this is 72. This angle is the same because these two angles are vertical angles, so they have to be the same. So that means this has to be 72 degrees as well. Okay, now let's do the measure of arc WV. So that's this one right here, WV. Well, I know all the way around is 180, and this is 72. So if I go 180 minus 72, that gives me 108, which would be this right here. Okay? All right. So now we need TW. Well, TW, I can just go, that's from here to here. That's 21 plus 72. So that's going to give me 93. Okay, so now what do I have left? I have a lot of stuff going on here, but I need to find TVW, major arc TVW. So that's from here all the way around. So I just need, looks like I need to add up 87 degrees plus 72 plus 108. Okay, so that was 159 plus 108 would give me 267 degrees. Okay, so really just using a little bit about circles and what we just learned to kind of put all that together. It's like a little puzzle, kind of fun. Okay. Sometimes they'll throw a little algebra in there. You're still going to use just the same concepts to figure these out. Here this says find each value or measure. In this case, they want us to find x. Well, I know a couple of things here. I know this is 103. Okay. So, I want to figure out what this is, because I know this is 180, right? So if I take 180 minus 103, that gives me 77 here, which means this is 77. Okay. So now I can add I guess we could say another way to do this. I maybe am going a little too far here, but either way, I could take this away from, I could add these together and then take it away from 180. I could also say that this and this together would be the same as 103 because they're vertical angles. Those are vertical angles. So maybe that's how we'll start. 18, there's a variety of ways you can do that. Okay, so I have 18x plus 13 Okay, so then if I subtract 13 from both sides, 18x equals 90, divide by 18, and we get 5. Okay, so that's 5. Well, that wasn't too bad. Okay. All right. Do you remember what circumference is and what the formula is? So the circumference, if you'll remember, is the distance around a circle. It's the perimeter, but for a circle, right? So we call that circumference. And you can find the circumference in a couple of different ways. One is C is equal to 2 pi r, or you could say C is equal to pi times diameter. Remember, r stands for radius. So either one of those is fine. So if we want to find the length of an arc, the length of an arc is just the distance. How long is this section of the circle, right? So if I want to know how long that circle is, I would just take that fraction of all the way around, right, of the circumference. So that's the formula, is really just that, is you say, well, the length of that arc is going to be equal to x divided by 360. So x is our central angle here, right? So whatever that angle is, that's a fraction of 360 degrees. So we're going to take that fraction, let me write a little bit better parentheses than that. That fraction times the circumference all the way around. So a fraction of the circumference. So the circumference, again, you can do pi times diameter or 2 pi r. I'll just write times 2 pi r. If you used pi times diameter there, that would also work. So this is your formula to figure out any arc length. Okay, so we're going to apply that and give it a try here on a couple of problems. Okay, so I want to go through really just two. All right, so it says find the length of the arc to the nearest hundredth. Okay, so I'm trying to find this bolded arc. So we're going to say L is equal to, I need the central angle or the arc length in degrees. I know what it is. It's 107 divided by 360, whatever that fraction is, times 2 times pi times r. Now, I have the r, the radius is 6. Okay, so you can enter this into your calculator just like that. I will do this once just so you know how it's done. Let me do it on my calculator here. All right, start it up. Okay, so I had in parentheses 107 divided by 360. So I want to keep that in parentheses right there. Okay, so now I'm going to go times 2 pi, and then times our radius, which is 6. So you see I get 11.21. We're going to round to the nearest hundredth, so 11.21. And then because this is a length, it's just regular units, so this would be meters. So that would be the length of the arc there. In bold would be 11.21 meters. So hopefully that makes sense. And we'll go from there. All right. All right, this says if the length of EB is 15 centimeters, so that's, let's just label that 15 centimeters. Okay. Find the length of arc CD. All right, so now this, I'm getting a bunch of texts from my family. Awesome. So the length of this arc CD, we need to figure out what that is. But it's helpful to know what this angle is first. I would need that central angle. Well, I know that all the way here is 180. So that would give me this being 180 minus 68, which is 112, right? Okay, so now I can find the length of that by saying, all right, the length of arc CD is going to be 112, it's not very good, 112 degrees over 360 degrees, whatever that fraction is, times 2 pi times 15. So, all right, now I'm going to do all of that. And if you multiply all that out on your calculator, you should end up with, and again, this is just calculator work. So hopefully, and then rounding it appropriately, we should get this. 29.32 centimeters. Okay, cool. I hope that's making sense. All right, so then the other thing is an area of a circle. Do you remember that? Well, same kind of circle here from before, that same picture. Area of a circle is pi r squared. Okay, so in this case, you'd go pi times 12 squared, so pi times 144 and whatever that is. Okay, well, sector area just does the same thing. It's just a fraction of the whole area. So your fraction is going to be x over 360 degrees, I guess those are both to be in degrees, times pi r squared. So that's how you find that. Okay, so that's really all you have to do, and then you just go from there. So let's try this. All right, so if I want to know what this is, this section here, it's called a sector, what the area of that is, I'm going to say the area is equal to 60 degrees over 360 degrees, so a fraction of the whole circle, times pi times radius squared, so 14 squared. Okay, and then you just type that into your calculator to figure that out. So I'll just do that on my calculator here. 60 over 360. Okay, well, apparently it's disappeared again. So let's try this. All right, never mind. Seem to be having some troubles. I'll just do it on my manual calculator. Let's go back to this. All right. 60 divided by 360 times pi, and then times 14 squared. And you get 102.63. And then these are square units, so this would be this square yards. That's the abbreviation for square yards. Okay, so hopefully that makes some sense to you. Now let's try this. A little bit trickier problem. This one says, all right, I am gonna give you the length of this arc right here. That's the length of the arc is 31.75. And they tell us a little bit of information on the inside, but it's not the central angle that we want. So we know that all the way from here to here is 260, so that means this must be 100 degrees, right? Because it's got to add up to 360. So the first thing I'd want to do is use my arc length formula. So I'm going to say L is equal to x over 360 times 2 pi r. So I would need to know that first. So I know what x is, it's 100. And I know what the length is, it's 31.75. Okay. And then times 2 pi, and we don't know r. That's what we want to find. Find the radius, and once we know the radius, then we can find the area of that shaded sector. Okay, so, all right, well, let's do it. Okay, so if I say 100, I'll use my manual calculator again, just to make sure we don't have any more issues. I'm really just gonna multiply this part here and figure out what I get. So if I do that, I get 1.7453 times r, right? So now if I just divide to solve for r, I divide by 1.7453, we'll say. Okay, so I'm going to say 31.75 divided by 1.7453. I get 18.19. Okay. So now if that is my radius, I can find the area of the sector by plugging that in and going from there. So let's take a second to do that. A is equal to still 100 times pi times, I'm going to run out of room here, 18.19 squared. So I want to type, that doesn't look the best, does it? I'm going to type all that into my calculator, but that should give me times pi times 18.19 squared. We get 288.74. And then this is feet, but because this is a sector, this is going to be square feet. So there we go. So we found the radius, and we found the area of that shaded sector. So I hope that makes some sense, just with central angles, arc length, and area of a sector. You can go ahead and give this assignment a try. Don't forget to write it into your planner. Good luck.